Welcome to a video on a VBA spreadsheet for hourly short grass and tall crop reference evaporation from AWS data. There are some contact details. Why use hourly weather data? Hourly weather data is a better descriptor of the microclimate than is daily, weekly or monthly data. So it makes sense then to calculate reference evaporation using hourly weather data. VBA is a useful tool for performing sophisticated calculations behind the scenes of the user at the Excel interface, but allows the user access to those calculations. To access the VBA code, it's Alt function F11 on a laptop. This is the function that I've used, ETO_R, and there are various user options that are specified. I won't go through the code, but we will look at in detail on how to access this function in Excel. The spreadsheet uses conditional views. Conditional views is a useful way of navigating through a complicated spreadsheet. To access custom views, it's Alt V, and we could go to references. The two key references are the FAO 56 and the ASCE protocols for determining reference evaporation. Let's look at the theory. The basis for the calculations is the Penman-Monteith equation, written in a form with Cn as a constant in the numerator and Cd as a constant in the denominator, which have different values for grass reference and tall crop reference during the daytime and during the nighttime. The canopy resistance is also important, which is 50 seconds per meter during the daytime for grass and 30 for tall crop, and otherwise during the nighttime 200 seconds per meter. Let's look at the station information. The data is for University of California at Davis, California, and we need to specify the latitude, the longitude of the standard meridian, the elevation, and something we seldom change, the grass reference reflection coefficient, and the measurement height of the wind speed sensor, from which the wind speed at 2 meters is calculated. Let's look at the VBA function before we look at the outputs. The spreadsheet uses the function ETO_R for determining short grass and tall crop reference evaporation, as well as their radiative and aerodynamic components. The inputs include the station parameters, which we've looked at, day of year, time of day, and then canopy resistance, which is either 50 seconds per meter for short grass or 30 for tall crop, and then the weather data. Solar radiance in watts per square meter, air temperature in degrees Celsius, the atmospheric water vapor pressure in kilopascals, and the wind speed in meters per second. The station inputs include latitude, longitude as we've seen, and just take note that this VBA version makes no adjustment to the cloudiness factor for when the sun falls below a user-defined angle. To invoke the function, we type equals ETO_R bracket option 1. And option 1, or option, the ETO option is 0 for reference evaporation, 1 for radiative, 2 for aerodynamic, 3 for net irradiance, 4 for net solar, 5 for net infrared, and 6 for soil heat flux. We then input the latitude, the longitude of the standard meridian, and these are names in the spreadsheet, so we don't have to put the actual values here. We'll pick it up from the station table which we populate, all the way to albedo, and then day of year, time of day, the canopy resistance, either 50 or 30, 30 for tall crop, and then the weather data, the solar, the air temperature, the water vapor pressure, and wind speed at 2 meters. Let's look at the VBA outputs. The input data, from the data logger we get the dates and timestamp, from which we can calculate the year, the month, the week number, as an integer, the day of year between 1 and 366, and then time of day for every hour of the entire year. Then the solar radiance in watts per square meter, the air temperature in degrees Celsius, and then either the relative humidity as a percent or the water vapor pressure in kilopascals and the wind speed in meters per second. And from that measurement height wind speed, the wind speed at 2 meters is automatically calculated. The wind direction and the rainfall are optional. To populate the cells for the components of reference evaporation, we use the function equals ETO underscore R bracket, 1 for the radiative component, then the names lat long all the way to albedo, K50 for the day of year, L50 for the time of day, 50 for the grass reference canopy resistance, 50 seconds per meter, and then the solar radiance, the air temperature, the water vapor pressure, and the wind speed at height 2 meters. We can copy that formula in the formula bar to the adjacent cell, change the 1 to 2, keep everything else the same. And that will give us the aerodynamic component of grass reference. To get the grass reference evaporation, we copy to the adjacent cell and change 2 to 0, keeping everything else the same. If we wanted to populate this cell, we copy it from the previous cell. We change the 0 to 1 and 50 to 30 to get the tall crop reference evaporation. Copy that formula into the adjacent cell, change 1 to 2 to get the aerodynamic component of tall crop, and change the 2 to 0 to get the tall crop reference evaporation. Copy that cell across to get net irradiance. We change it to 3 for net irradiance. And we use a multiplying factor because in VBA the irradiances are all in megajoules per hour per square meter. So mega is times 10 to the 6 and an hour is 3,600 seconds. Copy that cell across, change 3 to 4, keeping everything else the same, 4 to 5, 5 to 6. Copy all of these cells downward, and that will give the hourly values of the various components for each hour of the entire year. The rest of the video is how to reduce those hourly values to, for example, daily, weekly, monthly. For daily, we create cells 1 to 366 in column AJ. We then use the formula sum IFS function, which has got 3 parts to it: a sum range, a select range, and a select value. The sum range in this case is column Y, because Y has the radiative component for grass. The select range is column K, because K has the day of year as an integer. The select value, the first value we want to select is day of year 1. So that's AJ50. We copy that formula across, change Y to Z to get the aerodynamic component, keeping everything else the same. Copy that formula across and change Z to AA to get the grass reference, AB for the radiative component for tall crop, AC for the aerodynamic component for tall crop, and AD for the tall crop reference evaporation, keeping everything else the same. If we want the rainfall, rainfall is an input column S. That'll give us the daily rainfall for day of year 1. The net irradiance is in column AE, and again we use a multiplying factor because we want it in megajoules per square meter as a daily total. We multiply by the integration period of an hour, which is 3,600 seconds, and divide by 10 to the 6 to express it in megajoules per square meter. Copy that one across to AF for net solar, AG for net infrared, and AH for soil heat flux. Copy those cells downward to get the totals for each day of the year. To do it for monthly, we would create 1 to 12, weekly, we would create 1 to 52 and go through the same procedure, selecting Y as the sum criteria, selecting J in this case, because that's the week number. AW50 is the first week of the year, and we divide by 7 because we're getting the total for the week. And then we just copy those across and down to get it for each week of the year. Similarly for monthly, 1 to 12. For monthly, we have to divide by the number of days in a month, the average number I've chosen instead of the actual number. I could have used the actual number. And that will give us the monthly totals for each month of the year. I want to look at a validation of these calculations, Alt-V. This is for University of KwaZulu-Natal in Pietermaritzburg, South Africa. The agrimeteorology instrumentation MAS system, the weather data there was used to calculate the hourly evaporation for short grass reference and tall crop reference, and a data logger was used to compute it hourly, short grass and tall crop. And here's the comparison of the data logger and VBA for short grass. Those are the hourly values for the entire year, and pretty good agreement. And that is the comparison for tall crop, also pretty good agreement. Slight differences I suspect due to the cloudiness factor. I'd like to thank you for watching this video on grass reference and short crop reference evaporation using Excel VBA. Cheers.